Okay, first thing I'm going to do is just give you the answers for your homework. So hopefully you have it out. I don't want you to necessarily look at them too hard right now. I'm just going to go through the answers real quick. Just write down the real answer next to your answer. And once I'm done, you're going to pause the video and talk about them with each other and see who got the right answers, who got the wrong answers, and work on stuff if you need to. So here we go. 21, there's no limit, square root's negative. 25 is 0.5. 27, negative 0.5. And 31 is negative 1. Like I said, just write those down next to your answers real quick, and you're going to go back to them. 41 is 1. 42 is negative 1. There you go on 43. It goes, or I'll just read them so you can look at your paper and write. I'll just go A through J. True, true, false, true, 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 false, 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 false. Okay, 45. Here's A, B, C, D. Goes 3, negative 2, does not exist. 1, 47. And actually, you could just look these up in the back of your book. I forgot. 47, they're all negative 4. It's all the same. 49, you can look up in the back of your book. So really, the only ones I needed to give you are the evens, and there's no more evens. So, and then 49, 4, negative 3 does not exist, and 4. Right now, pause this video, take 15 to 20 minutes, check to see if you got the right answers. If you got wrong answers, talk to someone, talk to a neighbor, get them figured out. If you got all the right answers, help someone, check each other. Turn to a partner. Ready? Go. Pause it. Take 15 minutes, because now I'm going to move on to the new stuff. And, well, you probably already paused it, but we'll go over those more in depth tomorrow if you need it. So today, real easy stuff. Properties of limits. I'll try not to mumble. Let's say we got two functions. We got f of x and we got g of x. And let's say we know the limit on if as x approaches c of f of x. So just as x approaches some number, the limit of this function is, the book calls it L. And for g of x, if we do the limit as x approaches that same number, c, we get m. So that's just, we have two different functions. If we do the limit as x approaches the same number, we get two different answers. But then here's the properties. I'm just going to write one of them down and then do an example. So if you have the limit as x approaches c of f of x plus g of x, rather than trying to add those functions together and do anything there, if you know the limit of this one is L and the limit of this one's M, if you add them together like that, your limit will just be L plus M, just the addition of the limits. And this works for addition, subtraction, multiplication, division, exponents, all kinds of stuff. So I think it'll make more sense with some actual, with some numbers. So let's say you have the limit as x approaches 3 of f of x. So some function, and you know that limit is 2. And then you have the limit as x approaches 3 of a different function, and you know that limit is 5. You can use those. Let's say you're asked, what is the limit as x approaches 3 of f of x times g of x? Well, that's just 2 times 5. It'll be 10. It's that easy. Now, we could prove this, but we don't have time for that. So another one, like the limit of g squared of x. So you're squaring the function rather than, actually squaring it. You just take the limit and square it, so it'd be 25. It'd be 5 squared. If you add the limit as x approaches 3 of f of x plus 3, well, you would just take this limit, add 3, you'd end up with 5. Easy deal. That's all it is to it. You're going to have a few problems like that. Let's talk about sandwiches. Little sandwich theorem here. It's called the sandwich theorem because it kind of looks like a sandwich. Sandwich. I always spell sandwich wrong. I always put an extra H right there, so I don't know about this stuff. Sandwich theorem. It's basically saying if we have 3 functions, so we got g of x, f of x, and h of x. If I know that g of x is less than or equal to f of x, and f of x is less than or equal to h of x, I can draw some conclusions. But you might be wondering what this means. Let's say h of x is something, I don't know, some weird thing like that, like the top of a cosine wave or sine wave. Or I shouldn't say top, but part of it. Alright, there's h of x. F of x is some weird dampened thing like this, which we could draw those. So notice f of x, the whole function is below h of x, and it never goes above it. That's what this means. It means f of x is less than or equal to h of x. So this function is always below h of x, right? I can put my x and y axis if I wanted to, but that one's always below that one. And then g will always be below f, so it could be another like sine wave down here. Here's g of x. So there's my sandwich. Some crooked bread, some lettuce, or whatever. I have one function that's sandwiched between 2 others, right? And if I'm looking at, this will mostly happen with sine and cos waves. It's not like a parabola where it always goes up forever. These don't always go up forever. So it's possible to have one that's always above another one that's always above another one. This can happen. So if this does happen, if the limit of g of x as x approaches some number is equal to the limit as x approaches that same number of h of x. So it's saying g of x and h of x have the same limit. So like let's say I'm right here, here's my c. As g of x gets close to c, I'm approaching some number on the y-axis, right? And h of x is, if h of x approaches that same number, then it's true that the middle function will also approach that same number. So if the top and the bottom one have the same limit as we get close to some number, or just if the top and the bottom one have the same limit at some point, then that middle one will have to have that same limit also. An example of this. If you had to find that limit, you probably couldn't do it. It's x squared times the sine of 1 over x. Pretty weird. You could probably graph it. But we could also use the sandwich theorem. And the way we do that is, we know we have a part here with the sine of 1 over x. We know that the sine function, right, a sine graph, just regular old sine of x. Alright, it looks like this. The highest it goes is 1 and the lowest it goes is -1, right? We can see that on the unit circle. No matter what we plug in for x, the y coordinate around the unit circle is always between -1 and 1. So the biggest, no matter what I plug in for x, the biggest this whole thing could be would be x squared times 1. Because the biggest that could ever be is 1, right? No matter what I plug in for x, the value of this will always only be 1 at its most times whatever x is, right? I don't care what it is there. This whole thing is just 1 at most. So the biggest this could be would be x squared. The smallest it could be, no matter what I plug in for x, the lowest this value could be, it'd be -1. So that'd be x squared times -1 would be -x squared. Those are kind of like my highest and my lowest functions. Like this will always be bigger than this. This will always be smaller than this. Or equal to it at some point. Right? Remember up here it said less than or equal to. Right? So x squared will always be either bigger than this or equal to it. -x squared will always be smaller than this or equal to it. So here's my biggest one, here's my smallest one. If these two limits are equal, so I can do, or I should write it like this. Let's write it like this. I know -x squared has to be less than or equal to x squared times the sine of 1 over x less than or equal to x squared. Alright, this is like my g of x, this is like my f of x, this is like my h of x. So I gotta check the limit of my smallest and my biggest one. I wanted the limit as x approaches 0, right? That was my original question. So if I check the limit as x approaches 0, my smallest and my biggest, if those are the same, then that middle one will have the same limit. Because it's a lot easier to do this limit, the limit as x approaches 0 of x, whoops, I'll do x squared first. It's a lot easier to do that limit than that one. So I check the big one. Hey, I just plug in 0 for x, 0 squared, I get 0. Do my small one. Limit as x approaches 0 of -x squared. Hey, that's easy, it's 0. They're the same. If these two have the same limit, this one will have the same limit. So I know that my limit is 0. So in your homework, I want you to try a couple like this. Kind of do like we did here. Think about what the biggest this could be. Think about what the smallest it could be. Write it like this. Find the limit of the biggest one and the smallest one. And if they're the same, that'll have the same limit. I'm guessing there'll be plenty of questions about that tomorrow. So that'll be fun. Let's see. Here's some new homework for you. We can go over the answers to everything tomorrow so that we can get ready for our first quiz on Wednesday. Pause it if you need to. So I'm shutting this off.